Yeah, I can start now.
A very good morning to all of you. Myself, Dr. Subhatra Murugan, Head of Electronics Engineering, VLSI Design and Technology. On behalf of the Department of Electronics Engineering, VLSI Design and Technology of RMK College of Engineering Technology, I am truly delighted to welcome you all for this 28th Generic Talk Series. At the outset, I express our heartfelt gratitude to our magnanimous management for their constant encouragement and support, and to our respected principal for guiding us in all our academic endeavors. I also extend my warm regards to our Dean Academics and Dean Research for this continuous motivation in promoting such knowledge enriching initiatives. It gives me immense pleasure to welcome our distinguished guest speaker, Dr. Rame Gowda Dinesh, Managing Director and Head of Business at Samsung Electromechanics Bangalore. Prior to joining Samsung, he has served in reputed organizations such as Amazon, Honeywell, and HCL Technologies. He was also a postdoctoral fellow at Seoul National University, Seoul. Dr. Dinesh's area of research interest include image processing, pattern recognition, computer vision, and machine learning. He has to his credit over 75 publications in reputed international and national journals and conferences, and an impressive 27 awarded patents. He also serves on the editorial boards of several journals, acts as a reviewer for international journals and conferences, and has been a program committee member in many global forums. As an academic mentor, Dr. Dinesh has successfully guided 6 PhD students and in presently guiding 3 more. In addition to the numeric academic and research projects, he is a life member of professional societies, including IEEE, Computer Society of India, the Society of Statistics, Compute and Applications, and International Association of Engineers, Hong Kong. He also contributes significantly as a member of Board of Studies, Board of Examiners, and advisory committees across several universities. We are indeed honored, sir, to have such a distinguished personality with us today to share his insights on Edge AI, concepts, architectures, and applications. His presence will truly enrich this session and inspire all of us. Once again, I warmly welcome our esteemed speaker, Dr. Dinesh sir, our respected principal, deans, faculty members, students, and the online audience joining us through this YouTube live. Thank you, everyone. Sir, Dinesh sir, the forum is
Yes,
yours
ma'am.
now. Yeah.
Okay. Yeah. Good morning, all of you. And madam, thanks for a wonderful introduction. And so it is indeed my pleasure to have an interaction and share my views and whatever the little experience I have gained, like so working over spanning 20 years in the area of artificial intelligence and specifically with respect to its AI in last 5 to 8 years. Yeah, so let me share my screen and so is my screen visible?
Yes, sir. Visible, sir.
Yeah, okay. Yeah, so good morning all. Today I'm going to talk about the topic Edge AI. So some of the preliminary architectures and what are the kind of applications. Probably like the topic itself is very apt and one of the big thing like probably like last 5 to 7 years there is a lot of traction with respect to the artificial intelligence. I think artificial intelligence is almost becoming like okay, so a new paradigm where the way of computing or the way of computation or way of solving the uh, problems or day-to-day work with the computers has significantly changed over 5 to 7 years because of a lot of advancement in the area of artificial intelligence per se. and specifically with respect to the deep learning, transformers, and so few advancement in the area of machine learning itself. So now people are talking about like so the different levels of artificial intelligence, how it can be applied for various domains. Now almost like okay, so though artificial intelligence was a branch of like okay, so initially it was coined by computer science, and then like so with under the mathematics. But now I think almost artificial intelligence is becoming a domain agnostic. That means like there is hardly like okay we cannot imagine any domain where AI is not penetrated. You take medicine, you take agriculture. I think it has penetrated to almost all areas, and maybe like next uh, decade or so, I think probably like it will significantly change and it will significantly enhance and optimize the way we are working. Like so, I think probably today we are talking about the physical AI. Like okay, so now another big thing. Like okay, so now not only restricted to the software and actions. So now how best it can be put into the field operations as well. Like so through the help of robots and other things. So that is the beauty of artificial intelligence. Of course, there are like so there are a lot of challenges. There are like a lot of concerns being expressed because of the artificial intelligence. So now, I think probably like one of the major concern many people are expressing is how artificial intelligence is going to take out the jobs. I think probably like in my opinion, artificial intelligence, of course, like so some kind of jobs will go away because of the automations and other things. But AI itself is not going to take out the job, but rather AI will the person who is not using AI is going to lose out the job. So that's the kind of statement probably we need to. That means if somebody is really good at AI, if somebody is started practicing the AI and how to apply AI to solve the different problems, I think probably like they can significantly uh, solve the problems in a very efficient and effective manner. Okay, so that's what the background. So now like okay, so today's topic is mainly like okay, I will be talking about edge AI. So that means so we know like okay, AI has got like various facets. Is yeah, can be solved like so in a different frameworks and the platforms. But when it comes to apply the AI for solving the problem in a near field or like so the in a efficient and effective manner, so how best like so we can leverage the edge devices, how we can put the AI on the edge devices to solve the problem. That's the kind of objective, that is the topic of today's study. Okay, the topic of session is Edge AI. So we'll talk about few architectures. Of course, like so there are few applications. I also mentioned like okay, so this is a next big thing in AI. We'll say like why it is a next big thing in AI actually, because already AI is being applied for various kind of application and the practices. But when you put it into the edge devices, so it can enable whole lot of other set of problems that can be effectively solved. Okay. So before starting that, I think briefly I will touch upon what is artificial intelligence. Okay, and then like so the background about what it is, brief background. So I think probably most of you are very familiar with what is artificial intelligence. Artificial intelligence basically like it is a performing the intelligent task, just like okay so the humans we feel like so we are the most intelligent animal on the earth. So just like okay so how best we can leverage computers, okay, to solve the problem with the help of computers. Okay, how to perform the intelligent task with the help of computers. Okay, so if I put it into the perspective of artificial intelligence, artificial intelligence basically it takes input just like a humans. So humans also like okay so we get the input from our sensory organs. So just like that, like so even the artificial systems will get the input from the various source, either in terms of the data or in terms of sensors or the images, etc., and so forth. and there will be a agent or the algorithm which will try to perform the operation. Okay, so this is what the artificial system. So where like just like okay, the brain process and perform the operation. Like so, we have an artificial agent, the set of programs which takes the input, perform the operation, and then produces the output. So then like okay, so it is similar to like okay, so the traditional way of computing, right? So even the computers takes the input, runs through the program, and produces the output. But what makes the difference between like so the traditional program and the intelligent program is so the behavior of the program in case of a traditional computing or the traditional programming. So the behavior of the program will not change. Okay, so that means even if you execute the same program after 100 years on different type of data, its behavior will remain almost similar. But when it comes to artificial intelligence or the intelligent system, its behavior will change. Its behavior will evolve. That means, so today I am performing certain task. See, for same thing, like so you assume that okay, you joined as a faculty member, like so very fresh, you completed your post graduation, you joined a uh, uh, for a faculty position in an engineering college. The way you are teaching today maybe like okay so it will significantly change over a period of like maybe like it will be the way you will teach after 3 years or 5 years we can see like so drastic change but you'll be teaching the same course you'll be teaching the uh, same content but the way of delivery or way of like so articulation of your thoughts and how to deal the students like okay so how to make like okay so more attentive how to engage them so those things will change right so similarly how did you acquire that because you are intelligent like so over a period of time you try to see how the students behavior when the students will get motivated so what kind of engagement is a right mode okay and what is the grasping level of the students how they are grasping the concept to make the concept more understandable how to what kind of examples need to be given these are the things you will try to learn over a period of time right in the similar way the artificial intelligence systems or the intelligence we call them as a intelligent programming or the intelligent system because their behavior is expected to change over a period of time if not change means like so basically it is expected to evolve to perform much better much efficient and much optimized way of performing the task same task as the time goes. So that's why we call it as an intelligent system. So typically, otherwise, it is exactly similar to your traditional programming, but except that, okay, so it has a capability of learning. So with that learning feedback, it evolves its behavior to perform much better and solve the problem much effective and efficiently. Clear? So again, like so when it comes to artificial intelligence system, what kind of output it can generate? It can generate the text. So typically, like okay, if you are using a chat GPT, your input is a data. So in terms of like so the text and output will be again be text. Okay. On the other hand, like so if you put this into the whatever the action like so the algorithms onto the robot, so probably like so you will have a in terms of a movement. So if you implement a AI agent, so you will have some kind of actions output. Okay. So depending on the type of problem what you are solving and what kind of AI model you are building, so output can be either in terms of a action or it could be a movement or it could be a text. Right? So, so there are different levels of intelligence. Just like okay, what humans also we try to segregate the humans based on the intellectual capability, right? So similar to that, even the artificial intelligence system can also be graded into different levels of intelligence. Okay, from that right, like if you take a class you say like so some students are very very smart they are very intelligent some are average and some are like so I think like so they are less intelligent like so so that's how we try to segregate so in the similar way we also like so the artificial intelligence can be broadly classified into one of the three categories okay levels of based on the levels of intelligence so one is artificial superintelligence artificial superintelligence definition is this artificial systems are much more intelligent than the humans in almost all aspects of life. That means, as a humans, say somebody may be like so very good in one particular task, but he may not be very good in another set of tasks. Okay, but artificial super intelligence systems are expected to be like, okay, so the intelligent and super intelligent. That means they can outbeat, outsmart people in almost all aspects of life. If that is the kind of systems, I think probably then we call such kind of artificial intelligence system as a artificial super intelligence system. Right? So now the question is, okay, let me ask you a question. Whether those kind of systems are available today, or these artificial super intelligence systems are commonly available today? Can we use them? Answer is probably no. Like so, they are in the process of building, but they are not very quite common. Like so these days. So there is these kind of systems are like okay, so in the process of building, they are very very confined to the R&D labs to do a lot of experiment and like so to build it. Actually, probably like okay, if we go by that. CEO of NVIDIA. So he is very, very optimistic that okay, these kind of artificial super intelligence system can be a reality in the early 2030s. That means like maybe like 2032 or 33. These kind of systems may become more common. So that's the kind of prediction. But as on today, these kind of systems are not very common. Like so, you won't be able to see them commonly elsewhere. The next category of artificial intelligence is artificial general intelligence system. So these are the systems which performs on par with any person, like so the humans. Okay, so perform the action is like so they can only like okay so think similar to like okay, humans. They can make generated decisions similar to humans, not exactly like so performing the action similar to like humans, like so it may not construct a house by itself, because there are a lot of physical and mechanical limitations. But when it comes to generating the decisions based on the seen data, so whether these artificial general intelligence systems can generate the decisions similar to humans, that's what the definition. Like so, artificial general intelligence is systems or the machines able to apply the intelligence to any problem. That means the data may come from like okay, so the medicine, data may come from the agriculture, data may come from the education, etc. and so forth. So I get a different type of data. When these kind of different type of data has been posed, whether it is able to generate the decisions similar to that what humans can generate is what like so generally general intelligence. Again, if you ask the question whether these kind of systems are available, okay, let me ask you a question now. Is these kind of systems available today? Probably like okay, so not exactly like okay, so if not exactly similar to the human expert in a particular domain or the field, but these kind of systems are almost we are already started seeing those kind of systems are becoming reality with the help of GPT. Like okay, for example, GPT or Gemini or like so your cloud models. If you ask a question, if you prompt for whatever the kind of problem you are having. Like, so you want to plan a vacation, you want to prepare itinerary for your travel, or you want to get suggestion about some cooking recipe, or you want to get some suggestion about like so the financial analysis. You give the document and you want to get the summary. So those are the kind of things like so typically like humans are well versed and they can able to tell, right? See, for example, you watched a movie, and if somebody asks, what is the movie like? So, what's the movie? So, the duration of the movie itself may be like so 2.5 hours or 3 hours. But if you are well versed or you are intelligent enough to summarize that entire 3 hours movie into maybe like, okay, so maybe 3 to 5 minutes description, or like, okay, so even shorter, like, you probably can give the just summary in under 1 minute. Okay, so those are the kind of problem. Like I think probably we are already started seeing, but again, like we said, the performance is still like we said not very very acceptable at this point of time. But again, if we see like so the current trend, these kind of artificial general intelligence may be reality, maybe by end of this decade, like maybe 2029 or 2030, probably we will be having like so much more sophisticated artificial general intelligence system, which are able to solve most of the kind of problems actually, like so which can think on par with any humans at much faster rate. Okay, so that's the kind of growth we are seeing. And the last category of artificial intelligence is like so artificial narrow intelligence. So typically, this is what the machine learning system which we used to use, right? So those are the systems which are already available. Like so, that means if I have built a artificial system to solve handwritten recognition, it can recognize only handwritten recognition. So if I build a set of algorithms, intelligent algorithm to recognize the face, it can recognize the face. It cannot perform anything other than that. Actually. So these are the systems which are very specific to specific problem, and those systems are already available. And I think we already started using, and I think probably the kind of these kind of systems are now becoming like it's almost obsolete. So we don't want to build algorithms specific for a specific task actually. However, I want like this algorithm to be more generic for solving wide range of problem, and however it can gain a more insight and more expertise in a particular domain is fine. But I don't want to build like so the algorithms which are very specific to a specific domain. Is like so kind of people are already started moving out from that particular aspect. Clear? So these are the different types of levels of artificial intelligence. Like so, what we understood now till now is so we understood what is artificial intelligence, where we stand with respect to like so the building that such kind of artificial intelligence system, and typically like we are in the crossroad of like okay, so mostly adopting artificial general intelligence. That's where we stand, and as and we talk today. Okay, but we are like so very well poised to make it more effective artificial general intelligence and fastly moving towards artificial super intelligence. Now, on this kind of system, what next? How to apply it? See, algorithms is good. Like, okay, so we have a system. So it takes the data, it analyzes, and it will try to give the decision. But how to make them actionable is what the question. How to make them like, okay, so the I don't want to say, like you are all like okay, so very familiar with Chat GPT or Gemini models. So you can give the prompt and it can generate the answer, and like so again you need to perform the actions, right? Now, is it possible to make the actionable? Makes the how to convert the decisions, how to convert the suggestions made by the artificial intelligence system into actionable items. How to make them to perform? How to make the system to operate? How to make the systems to act? Okay, that's where we are moving towards the edge AI. Okay, so before we get into the edge AI concept, let us typically understand what is the IoT. Okay, so typically, like okay, if I ask anybody, like okay, so to build a simple IoT project, probably like okay, so the simplest example, most of people come up, or the most of the students come up is, say for example, how to water a plant. Very simple problem. See, you have a plant in your balcony. How do you decide when to water the plant? Or probably like okay, so you have an indoor plant. How do you decide when to keep the plant outside for the sunlight? Getting the point? So let us say this is the problem. Now, is it possible for a simple activity of like okay, so the growing a plant, indoor plant, making a decision about when to keep the plant outside? Because plant requires light to generate the to perform the photosynthesis through which it can generate the energy. It can generate its nutrients, which is appropriate for its growth. And similarly, like also when to water the plant. If you water too frequently, too much, the plant will die. And if you don't supply the water at the timely manner, so again, like so the plant won't grow properly. If this is the problem, like so typically what happens, like so if I see the same problem from the IoT, if I want to automate the process of this growing the plant, like so the watering and lighting the plant. So typically what I will try to do, I will put some sensors. What sensors? Probably like okay, I need to measure the moisture content in the soil to decide when to apply, or like so whether the moisture is sufficient so that water is not required. If the moisture level is low, I need to apply the water. At the similar time, similarly, you need to have like another sensor to sense the leaf color under certain conditions. Probably, oh, now the I need to put light. I need to give some light to the leaves to perform the photosynthesis. Okay, so that's it. Like so, these are the probably like so two sensors are good enough. Okay, I decide like so. There are a lot of sensors available in the market to measure the moisture content of the soil. At the same time, so there are sensors available to measure the moisture content of leaves, or even like so your cameras can scan sense the color of leaves. Based on that, you can decide like so whether the leaves are turning yellowish, so which requires sunlight or sunlight or any kind of light. So then you probably provide these sensors. You will procure these sensors from the market. You put those sensors onto the plant. You install them. Then the data from this sensor, whatever the sensed data, goes to some computer. So typically, I cannot use a full-fledged PC here. So generally, we use like with a very small microcontroller, which can take this data coming from the sensors. And so there is a small computer inside this computer, which will try to process the data coming from the sensors to see what kind of pattern, like so what is the moisture content, what is the moisture trend, and similarly like so the lighting conditions, like so the leaves color, or it could be leaves moisture. And then based on this analyzed data, the microcontroller will make a decision like so the moisture is below certain level, so I need to actuate to pump the water so that the moisture can be increased. So that's what the actuator actually basically will have a set of actuators. So this actuator will act as a switch. Basically, one switch, it will turn on the pump to turn on the pump to pump the water into the plant. So similarly, like so, there will be actuator, which will be again another switch. It will turn on the light. Okay, there are a lot of lights available, so which can give same effect as like with the sunlight to grow the plant actually. So that's it. So now this is what like so the complete system. Now look at the beauty now. So earlier, if I give this data, okay, my moisture content is like this, and whether I need to plant, your AI prompt can tell that okay, yes, now you need to water. Somebody has to put the water. Now, if I try to put this into a this kind of framework, now the entire process of AI algorithms and its sensing and then performing all together will become a reality. Okay. So then, like, okay, so if you want to store the logs and like store the behavior and trend, you can have a communication device, so which will put this data into so somewhere like okay, so the cloud. It could be cloud, could be your NAS network access devices in your home where all this data will be stored, or it will be connected to your computer or like say your web data. So where all this data can be stored, because this problem may not require like storing the data, but there could be a lot of other problems, right? Probably you need to keep track of like the trend. So then probably like so those things can be stored in the cloud devices. But most of your sensing, acting, and performing is acting close to your plant. That is what is very very important. Okay, this is what is very very important to understand why we need to have a edge devices or edge computing. Edge computing means if at all you want to perform certain actions very close to the field, okay, so then you need to have these kind of devices. Okay, then, like so what is great in this one? What is so difficult? Like okay, so IoT existed for some time. There are a lot of computers available. AI was available, but Why Edge, like so, all of a sudden, like so, it is gaining a lot of traction now. We'll see in the subsequent slides. Clear? So typically, this is what like so again the same problem. If I try to break it down further, right? So I think probably like so you'll have a soil sensor to measure the soil moisture, okay, temperature and humidity of the surrounding region, and local luminosity. Like so, what is the kind of light? Whether the room is having sufficient light. If the light is not sufficient, like so, basically these are the sensors which we can use. Okay, soil moisture sensor, temperature sensor, the luminosity, like so, lumens are the illumination sensors, okay, which can be used to sense. And basically, like we will have a microcontroller, which will try to process the data coming from this, and you will have a set of buttons, okay, to pump perform the operation. Like so, basically, these are the pumps to give the status about the pump, like or the switch actually, whether the switch is on or off condition. Okay. So based on this, like so, some actions will be performed. Like so, it will try to turn on the pump to pump the water. So similarly, like turn on the light to increase the lumens, etc. and so forth. Right. But what is the problem actually? Like okay, so that means like so these kind of problems, I think probably like if you're IoT students, if you're studying IoT, probably you might have already performed these kind of projects already. I presume that, okay, because these are the very very basic thing you need to learn as part of your IoT study, right? But what is the typical challenges here? If you talk about any IoT problem, what are the problem even today that we need to address? The typical IoT project issues are not the sensors. So the sensors are being developed. Of course, like so, for certain cases, you need to have a very very sophisticated sensors. But anyway, like okay, so the scope of sensor development is not within the scope of IoT or the computer science. Actually, basically, like so, that is a different, a separate field. Depending on the need and depending on the purpose, people are developing the sensors. Even the sensors are available, the problem is not completely solved. Okay, of course, there are problems with respect to the sensors, and of course like so some aspect has to be worked with respect to the controller of the computers, a small scale computer, basically like which requires the capacity to process huge amount of data, a burst of data. Okay, that is also like so now people are talking about like so very high scale fabrications, like so to perform the more number of operations. So that is also like so being parallelly being done. And actuators, like, so what kind of action? I think probably depending on like, so if it is only a switch and relays or the actuators, it is being done. So even with respect to like, okay, so the lot of development is happening in the area of robotics also to make robotic platforms more stable, which can perform 6 degrees and 9 degrees of motions. And like, so they can be very, very stable and dynamic, now perform the uh, kinematic actions similar to like okay, so the smooth kinematic actions. Okay, so those are all the one of the major problem in any of the IoT projects is one is power. Power means see basically these systems are put into operation near to the field, near to the where the problems are occurring. That means you cannot expect the most of the time these microcontrollers and like so the devices are expected to work on the battery powered. So when the moment it is a battery powered, how much charge, how much power you are consuming is very very critical. Because see these days the sweeping and mopping robots are very very common. I think most of you are familiar, right? See now, what is this robots will do? It will basically sweep your house. It will mop. Assume that okay, your house is a 3 BHK house. For a 3 BHK house, if you charge once, your robot should be is expected to perform the cleaning and sweeping and mopping of the entire house in one charge. Then it is practically feasible to use that kind of. But if your robot requires 10 times charging to clean your home, will you really buy it? Probably you may not willing to buy, because to clean once, it requires 10 charges. Every time you need to charge the robot to perform the cleaning operation, which may not be practically viable. Okay? So that's the reason, like, so building the systems which can perform the task at the same time consume very less power, because most of these devices, edge devices, are expected to work on a battery powered. So when it is a battery powered, we want the longer operations in a single charge. So that is one problem, like, so most of the, and another thing is, with respect to the, again, with respect to the power, is how many computations it can perform, what kind of data and what kind of data frequencies, and the data capacity it can handle. That's also very, very vital. Like, so your data, your sensors are pumping the data with very high frequency. Maybe one sensor is pumping the data at 20 kilohertz, and another sensor is pumping the data at 50 kilohertz, etc. and so forth. But if your processor is not able to perform the operations at the same speed, then probably, like, so it may not solve the problem, because sensor is capable of sensing. Okay, so the connectivity is already established to get the data at the same rate, but your computer is not able to perform the operation because of its low computing power. Then also, like, the problem is not effectively solved. In fact, these both the power consumption as well as the computing power is also very, very critical these days. Okay. And next is the connectivity. Connectivity is like, so whether when it what kind of connectivity you need to establish between the sensors and microcontroller and the actuators. One connectivity. Okay. So whether your connected data connectivity mechanism is able to provide, like, so similar kind of bandwidth, and if you collect the data, the preliminary analysis is done, and if you want, like, some more sophisticated operation has to happen in the cloud or the centralized processing unit. So then, what is the latency? Okay, how much time it is required to transmit the data from your microcontroller to the cloud or the centralized computing area, and perform the operation and get the result back, and then perform the actuation operation, right? So that also play a vital role, actually. When it comes to connectivity, so connectivity in terms of the bandwidth between the data transfer, bandwidth between the sensor to microcontroller and microcontroller to actuators, and at the same time bandwidth required to transmit your data from the communication device or the microcontroller to your cloud, and then, so, and what is the complexity of the infrastructure, like, so what kind of infrastructure one need to set it up. Okay, these are the paramount issues still exist in today's IoT. Got the problem, right? So when I talk about the power of computation, power of power consumption aspect, and connectivity, like, basically talks about the bandwidth to transmit the data between the sensor to multiple touch points. Latency, like, so the once the data is available, how much time it is taking to perform the decision. So that's what the latency. So it should not happen that, okay, so your sensors, like moisture sensor and light sensor, has sensed the data, provided the data to the microcontroller. Microcontroller is taking 1 day to process those data to decide, like, so when to turn off the pump and when to turn on the light. So then it is not going to solve the problem, because it is taking too much of time in performing the operation. Like, so basically, we need to address about the latency. There are certain aspects which requires near real-time operation. Like, so for example, if it's a autonomous driving, your car is moving at, like, so maybe 80 kilometer or 100 kilometers per hour speed, and if your sensors are giving the data, but your computer is taking too much of time to make a decision when to apply the brake, then probably, like this, it's not going to happen, right? Like, so it has to be, it has to give the response in milliseconds, if not in millisecond, at least in the case of seconds, actually. Otherwise, the problem is not the usage of this kind of systems are not acceptable. Clear? So These are the problems one need to address. And when it comes to like okay, putting AI on top of this IoT, the problem becomes much more complex, much more involved. Why? Why like okay, so the in IoT, my operation is just to get the data and perform simple operations and generate the result. But when it comes to AI, so there is a model. You need to able to host the model inside that microcontroller. So these days, so some of the models are like so very very large. I think probably like you might have seen like so the GPT or if not GPT like it was a Llama model. Okay, the code Llama or Llama models coming from the Meta. So they are having 80 billion parameters. So the model itself is so huge, like okay, so it can perform like with a certain kind of operation. But model like we're hosting that model on any small scale devices is not practical. At least you need to have like so the GPUs of the range uh, RTX 4090 or at least RTX 5090. And if you want to have like so the multiple instances with more number of tokens need to be added, then probably like people are talking about a 800 kind of GPU setups. If not single GPU, at least like the array of such kind of GPUs. But when it comes to like, okay, so the edge devices, it is not practical because edge device is expected to work on a battery powered mode. So it works with like, so the very, very, it is expected to be very cheap and it is expected to be put into the near field operations. I may not be having like so the similar kind of environment where like so a sufficient cooling and kind of a lab kind of IT infrastructure rack is available where there is a sufficient air conditioning, power is continuous power is provided. That kind of situation is not we don't have that actually. See, that means, so putting any of this AI concept onto edge devices require lot of operation. That's the reason. So these days we are talking about like, so the AI, okay, it's matured. Like we say, it is still evolving, but it is at the some level, like we say, the maturity status. But putting that edge AI onto the edge devices still require a lot of uh, efforts and operations. Okay. So typically, like, so this is how, if you put it onto the uh, AI on top of the IoT. So typically, this is how it looks like. So same thing. So we have a lot of sensors. See, these sensors are getting the data and putting into the system. Okay. So this is what like, so the system and from where this will go to the database. So this is the cloud. And generally, we try to perform the exploratory data analysis and then you build a model. What is this? Basically, like I'm not putting this onto the edge devices. Basically, we are trying to see how to build a model. So to build a model, I need to have a lot of data. This data I collected over a period of time. Go to the cloud and we will have a database and we try to analyze the data. And so based on this, you try to build a AI model. This can be offline. This is nobody is worried about this process. Okay. So once you build a model, well, how much time you take, what kind of infrastructure you use for building the model is not the problem. The problem is once the model is built, how to put it and how to put it to the operation is what is very, very important. In this case, we are talking about so collect the data, put it into the cloud, so build a large amount of database of the data. Now, with this data, you try to perform the EDA, exploratory data analysis. That means what is the data correlation? So if it is a low moisture, what will be the behavior? If it is a high moisture, what is the behavior? What is the cross correlation between these data? So light and moisture. So similarly, like so there could be a lot of dependencies and like so the correlation and between the data, right? So you try to analyze all these things to build the model. Okay. So basically, like so the model will tell that okay, when to turn on the pump and when to turn off the pump. Okay, on or off. So now, like, so basically, it will, this particular model will tell, okay, so switch on the pump, switch on the light, or switch off the light. Okay, if light has to be turned on, so what should be the intensity, illumination? Like, those are the kind of things. So you collect the data, build the model. So model is expected to give like so the response on these two outputs. So with respect to the pump and with respect to the line. So now if I try to put it all these things into a single system, or example, I assume that okay, so you will have a farm where you want to automate the process of this, like this is the control farming you're trying to put, and how to put this into operation. So basically, like you will have a lot of sensors installed in your field. Maybe you are having 1 acre or 2 acre of land. So with controlled environment, it will keep on measuring the soil moisture. So it will measure the local temperature and humidity. Either it can measure or it can even like so get it from the other devices actually, like based on the GPS and local weather prediction, right? It can predict and it can get the data. And then local luminosity means like so what is the lighting conditions. So these are the inputs. Basically, it will go to some microcontroller. So here I just mentioned 32-bit microcontroller. So now, like so for the powering, you can use the solar panel because you cannot rely on the uh, electricity board supplied power, right? So because it's already in the agriculture field, so power may not be available, or even if it is available, there is like so there is no guarantee about the interruption. Okay, so the continuous availability of the electricity. So maybe like okay, we'll have a small solar panel with small batteries attached to power this computer. So then we will have like so the set of switches. So from where you get the status, and then like so this microcontroller can control the pump, water pump, and the lighting switch, right? So why we are talking about this model, this cloud. Okay, I will tell you like so. So basically, like so, this cloud basically like will collect lot of data over a period of time. So that means every data, whatever the process data, right? It will be performing the operation here. At the same time, this data will be pushed into the cloud. I will tell you why it is pushed into the cloud. At the same time, so we are here we are mentioning about LoRa. I think probably like if somebody of you are working in machine learning or the deep learning aspect, LoRa means like it's a low rank adaptation actually. Basically, this low rank adaptation is when you build a model. I was talking about the GPT or the Llama model, right? So typically the models, AI models are very, very large size models. These models cannot be hosted onto a small scale computers like so 32-bit microcontroller. Okay, these requires the low rank adoption. Like so, low rank adoption requires like so, a lot of quantization, distillation method. So to convert the large models into small models, I think probably like that is another the important development happening in the area of language models, even in case of a GPT and other things. So we till now we were talking about LLMs, large language models. Now people are talking about large language models are good. They can solve wide range of problem, but there is a limitations of mass expansion of those kind of large language models for wider applications. Then that's the reason now people are talking about the SMLs. Okay, small language, sorry, SLMs. Okay, small language models which can perform operations on par with LLMs, but with a much which can be hosted on a much lower environment. Okay, so yeah, LoRa is a low rank adoption, so which will try to get the updated model, but the model from the cloud, host onto the 32-bit controller. It will try to perform the operation. Now you're trying to say like so this is so similar to like so the whatever the operation we used to perform here in the previous IoT, typical IoT, except for the fact that so this LoRa like so it's a model. So in case of a IoT problem, your logic is burned onto this like so it will be flashed onto your device. Okay, so there is no intelligence like so this algorithm even after 100 years if you don't flash the program it will perform the same kind of operation. But the beauty here is so here there is no predefined logic flashed onto the microcontroller, but this will work based on the AI model. Okay, so how to build the AI model? Previously, that's what I said actually. So you continuously get the data because the trend, the pattern, everything will change, right? Depending on the crop, depending on the season, these things can keep on changing. Okay, that means a single model may not be appropriate always. So this model also requires updation. So that's why I mentioned these data, whatever the data we measure here, it will also go to the cloud. In the cloud, it will try to see the model. It will try to see the drift in the model performance. If the model is not appropriate, the model will be updated, and that same updated model will be pushed to the microcontroller through the LoRa architecture. Getting the point? So this is how, this way, like, okay, so in this architecture, this is the complete architecture where we talk about how to powering, how to measure, how to act, at the same time, how to manage the model. So this is what, like, so the typically your model in operation, ML also put into place. Like, so it will continuously collect the data, update the model, updated the more recent model is available for the operation. It will try to see, like, so what is the current model being deployed, what is the kind of decision it is making, whether the decision is, like, so actually drifting from the actual performance. Okay, so entire thing is working in tandem, including your operation, putting in the, and all this operation now works without intervention of human, without, like, so by taking factoring the change in season, change in crop, etc. and so forth. With all these things, so it is basically trying to work. So this is how, like, so the edge a project can be built on top of IoT and edge AI. The main difference is this actually. In case of edge IoT, your logics are free flashed, whereas in case of a AI, so the logic is not predefined. It's performance as the basic definition of AI, right? So its behavior is expected to change, evolve over a period of time based on the type of data, based on the type of inputs it is getting. It should be always keep up to date, and it should perform the operation in much efficient and effective manner. Okay, so with this, we can completely build end-to-end ML system. So that's the way. What are the key aspects? Like, so somebody has to, like, so if you want to build a career or your focus in the case of edge AI, of course, you should be very, very good at the communications. So when I talk about the communication, so communication, building the communication protocols between your microcontroller and the sensors, and building again, like, so the communication protocols and the layers, communication layers between, like, so your microcontroller and the actuators. That is bare minimum, basic, essential thing you need to always build. Okay, that's what you will try to pick it up from your basic IoT study. On top of it, what are the things you need to do is how to build a AI model, how to analyze the data, how to make the data stack, data storage, and how to do the data drift analysis to study the distribution drift between, like, so the current model and, like, so the current of data trends. Okay, how to optimize those models, because you cannot keep telling that, okay, so I need more data and I will try to build a very complex model. That is not going to solve the problem, because ultimately you need to take care of, like, so what edge device or the hardware you are going to host, how to optimize those models. So that's where, like, so the model optimization comes into picture in terms of knowledge distillation, student teacher model, teacher student model, or, like, so the quantization, how to perform the quantization on the models. So basically, like, so we are trying to work towards low rank adoption. Like, so basically, I have a bigger version of the model. How best I can downsize this model, which is suitable for a low scale hardware device, and then how to build this entire system and the data pipelines in place, so that, like, so the entire system works in much more intelligent way, incorporating the AI. These are the fields, these are the aspects one has to be very, very careful, like, so to pick up the career in the area of edge AI. Hope, I think probably you are able to correlate now. Like, so how does edge AI architecture looks like, right? So I think probably, like, these things are, I think probably most of you are familiar, right? Like, so if you see, like, we saw artificial intelligence is a bigger area. So within that, we are talking about the machine learning. So machine learning is a very, very small subset of artificial intelligence. And whatever the deep learning and language models we are talking today, I think they are the very small subset of machine learning. Within that subset of machine learning, we have a edge AI. Edge AI is a subset of your ARML and tiny ML. So tiny ML is like, so basically like, okay, so we are not even talking about I'm not going to scale up my infrastructure to suit my AI algorithm. Rather than my infrastructure is already fixed. I want like, so see, for example, you are growing a tomato in 2 acres of land. I can put like, so maybe like you may ask to process like, so to automate this entire edge AI, I need to have like, so 25090 processor with all the AC condition. So then like, so nobody will try to invest in that one. Like, so probably like farmer himself will try to monitor it. So basically the problem, what is the challenge and the focus point here is, how can I enable the solution of like, so monitoring the crop in 2 acres of land with minimum investment as much possible. Okay, probably like, so whatever the architecture we discussed, right? Probably like, so, solar panel, probably it doesn't much cost you much. So probably like, so you can few thousands, you can get a sizable solar panel which can sufficiently charge the battery, which is suitable to power this 32-bit microcontroller. The sensors now nowadays they are becoming very cheap, and like, so they are like also like very, very cost effective. And pumps and other things, it's fine actually. But only thing is, you should not scale up like, so the when we talk about the edge AI, edge AI like, so doesn't by itself, it doesn't talk about like what is that downscaling the model. Okay, so basically edge AI means how best I can put the AI system very near to the field. That's what the field. But when it comes to tiny ML, I am trying to downsize the model, so which can be put onto the a small scale chips, small scale computers. Okay, so which can effectively perform the same task. So this is where, so two aspects branch out here. One is how to make your chip fabrication. When you are fabricating a chip or a microcontroller or microcomputer, you should also consider the factor that, okay, you should be able to support this many number of computations in terms of the how many operations it can perform, and what should be the memory it can support, minimum amount of support memory it can support. One, at the same time, from the AI standpoint, how best I can downsize the model, AI model, to be suitable to a targeted architecture or a targeted chip. Okay, these are the two aspects which are going to be going to stay as a main focus or the mainstream study in at least next uh, 7 to 10 years. Okay, why I'm telling to 7 to 10 years means, now AI's penetration has already done. AI is started producing the results, a desirable, acceptable results. But now the question is, how best I can take this AI to the real operation, real field operation, without significantly increasing the cost of infrastructure investment. Okay, so because of this, there will be a lot of development. Like, so, if somebody asks like, so we started about the discussion about, there is a lot of negative impression about the AI, right? AI is going to take out the job. Of course, like, so AI is going to take out a certain very routine jobs will be taken out. At the same time, what kind of AI jobs will be created? So there will be a lot of AI, because now everybody started want to accept the AI. They want to deploy the AI. They want to utilize the AI. But different type of operation, different type of field, different type of work they are doing. Now, all these things requires building a small models, optimizing the models, analyzing the models, building those kind of AI model, and then optimizing and distilling those models to be suitable in the small chips. So this is one set of jobs it will create. At the same time, when it comes to like, so the chip fabrication, right? How to make your chip much more efficient, how to increase like more number of operation in a small scales, and how to make the chip cost itself is like form factors, and like, so the chip fabrication in under the control, like, so that chips can become much more affordable. So from both this aspect, lot many jobs will be created. Okay, so that way, don't worry about like so losing out the job for AI. AI is okay, so it is removing certain amount of jobs, but in the similar direction, there will be lot more number of jobs will be created. Only thing is we need to upskill and reskill in the right direction. That is what is very, very important. Clear? Yeah, I think probably like so if we see the uh, different type of hardwares, so we are going to it is expected to support like video, images, vibrations, okay, and then like so the live sensors, and then like so the lot of signals coming from like operations, audio. These are the different type of input devices or the hardwares we need to integrate. So why I'm trying to talk about this one is so that means going forward, so the data may be coming from a wide range of hardwares. I think when we talk about like so the connectivity between the your IoT platforms or the your edge devices, so we should have a framework to support like so these kind of wide range of hardwares. Okay, when I talk about the wide range of hardwares, these hardwares may be coming from like wide range of vendors. There should be like lot of standardization aspect, interoperability aspects, how to connect the data coming from this format, and how to enable like so there will be like okay, so the one we should have a like okay, so the interface layer here itself, or your sensor should take these aspects into account. So typically, like so again, like so we have a wide range of the hardware, the computers. So typically, like if you take a Raspberry Pi Pico board, so it is very very small scale. It can perform certain kind of operation. Like so, basically, like if your problem is just anomaly detection based on the sensor data, so, so you will have a continuous sensor data, and you need to see like so if there is any abnormality in the sensor data, probably you can use this kind of board. So probably if you want to perform certain kind of more sophisticated operation like okay, so keyword spotting and audio classification. Audio classification is either the classification of user who is talking, or like so what is the kind of audio he is talking about. So basically like so probably we need like Adreno Nano kind of board. Okay, Adreno Pro, so probably it has a Cortex M7, so it can even perform like so not only the it can perform the image operation, okay, like image classification, etc. and so forth. So then if you go to the much more sophisticated hardware like Raspberry Pi and a smartphone and even Jetson Nano, it can perform object detection and complex voice processing, video classification, etc. and so forth. Okay, so that means don't always expect like so the depending on like so what kind of activity, a activity you are trying to perform, what kind of problem you are solving. You also need to decide what kind of hardware is appropriate. Okay, these hardware could be like so the ones which are ordinary readily available from the market, like Jetson, NVIDIA Jetson, or like so the existing smartphones, etc. and so forth. Or sometimes you need to customize the hardware. See, customization of hardware comes into a picture when like so you have a plan to mass expansion. Like so that means you are going to sell like so those kind of chips or the hardwares for wide range of application. So that means you are productizing certain concept and you want to customize the chips, then it will work. But for some of the application where you need to just apply this for a one-time operation, like so then probably like so the customization of chips may not be appropriate. Then probably you will selecting appropriate existing boards or the edge devices. Clear? So then typically what are the tiny machine learning? Like so basically, if you talk about the tiny ML, I think already we discussed, right? It's one of the fastest growing field in the machine learning. The reason being mass adoption of AI in wide range of applications, so which requires development of algorithms. So tiny ML doesn't mean that okay, so developing only the algorithms. Of course, you need to develop algorithms which are very very small, so which can learn with a small amount of data, which can have less number of learnable parameters. So once the model is built, like so it can be hosted on a small chips. So the overall size of the model itself is very small. That's where the algorithm. And hardware means like so you also need to like when you are building a tiny ML. you also need to talk about take a factor about what kind of hardware it is, what kind of chip or what kind of hardware device you are going to use, and what is the complete software architecture we are talking about. What will be the interfaces? What will be the data exchange? What will be the bandwidth, interfaces, actions, etc., and so forth. Okay. So then it also requires on-device sensor analytics. See, I think probably like because most of these days, like so we have like so the sensors which can perform like basic analytics. I think probably if you are aware or not, like so even the CCTV cameras currently like which use just only the sense the image. Now like so even they can perform certain kind of basic analytics. Like okay, if there is a change in the scene, right? If there is any change, then only it will try to sense the change. And if it is a PTZ camera, it will try to adjust the pan, tilt, and zoom to focus onto a particular activity if there is any activities happening. Those are the kind of thing. And then how to make the system, entire system, like low power consumption, both from the point of chip operation and also like the algorithms which can take like the less power consumption. And typically like okay, so when to turn on and when to turn off the algorithm, certain kind of operation, also very very important. Like so for example, uh, again like so these are to some extent is already available, like even the CCTV cameras. So when the DVRs, one way of like so you can always keep on recording every event into DVR. So that way like so over a period of time your size will increase significantly. Or why you want to record every instant, like if there is only certain change, then only you try to record. In the similar way, try to find the options for low power consumption. And then like so how to ensure that okay so the your ML is always on. Okay, when I talk about ML is always on means it's not that okay the battery or the chip is on. So basically how to make your ML is up to date always. Because unless like okay so the whole purpose of bringing ML into this edge devices is the IoT is, I am not happy with like so the flashing the logic onto the device, so where its behavior is expected to be static. I want it to be more dynamic. When it is more dynamic, it should keep on learning, it should keep on updating the model. At the same time, like so the most updated and recent model should be available for your edge device. Okay, how to make that kind of framework. And all in all, so we need to always keep that okay so this entire operation is the low cost operated battery operated systems. So where we don't have a sophisticated environment where like so we'll have a AC to cool down and all those things, those kind of frameworks are the flexibility or the luxury we don't have. So these are the aspect one we need to focus when they are building the 10 ml system. Yeah. So we'll just quickly run through a few applications and then we'll wrap up today's session. Okay. So again, like so, what are the kind of operations you can do? Like so, from the edge A, from the predictive maintenance. So if you are putting into the industry application, so you can sensor you have lot of sensor to sense the motion, so the current and like so the field, etc., audio and cameras. So now in the industrial aspect, like so the predictive maintenance is one of the very very important thing. Like so you can sense lot, you can place lot of sensors onto the machines, and if the machine's performance is deviating, that means like so the sensors or the sensor data coming from these machines are deviating, then you can always try to take action. For example, if you are uh, see I think even probably like so most of the cars also a lot of sensors these days. If the car has got certain kind of behavior, right? See for example, if the vibration is abnormal, so it will sense the vibration. And if the sensor the vibration of the car or the device is abnormal, it will send a signal. It will say like so there is abnormality. And based on that, instead of like so waiting for the entire system to fail, you can always take a predictive maintenance. Like so you can see like so there is something wrong, and you can schedule the maintenance to see what is wrong with the spec. So that way the overall purpose of the predictive maintenance, especially when it comes to industrial aspect, is how best how can avoid the downtime of the operations. Okay, these days, so the in order to make a profit, You need to make sure that okay, your machines are running 24 bar 7 without any operation. Your production should not stop. So you need to ensure that. So you cannot wait like so when the machine is stopped or completely failed. You should not schedule the maintenance. Actually, you should not do the perform the maintenance. It should be always like so the predictive, proactive maintenance is what is the key aspect in terms of industry 4.0, and like so now we are talking about industry 5.0. All these mainly focuses or emphasizes on that predictive maintenance. Okay. So this is what like so typically we will try to perform in industry. Lot of sensor like vibration, temperature, motion, and like so those kind of sensors will be deployed onto the machines. So these data will be analyzed. Like so, is there is an abnormal pattern in the vibrations from the machine? Okay, if that is the case, then it will trigger the alarm and like so something. Okay, so we can always see like so what could be the wrong. The ball bearing has flown out or something, some subsystem of the machine is wrong or etc. and so forth. Right. So similarly, like asset tracking and monitoring. See again, like okay, I'm taking like it's a very few application in each area. So predictive maintenance, like it could be applicable for industry, even for white goods. Okay, infrastructure also like okay, so typically like buildings in Japan, okay, deployed with these kind of sensors where it can see like so if there is any stress at any point of the building, it will try to see like generate the alarms, or it can like so the self-healing mode will be deployed. Even in the automobiles, there are a lot of already lot of sensors are available, and like so the people are continuously adding more and more number of sensors to ensure that okay, so to make your automobile run smoothly. Okay. So similarly, like when it comes to asset tracking and monitoring, see these days, like so the logistics. Okay, so most of your like so what is that? High precious finished product or like raw materials are always available on the sea, on water. That means they will be continuously moving. Okay, now that there is a lot of dynamic situation. Okay, the idea, the things are being shipped from one country to another country, one continent to another continent. Okay, so if you don't try to track about like so this these logistics. Okay, so again in terms of logistics, like lot kind of operations, like in terms of the what is the weather condition, what is the sea tide, okay, what is the wind direction. These are all be continuously being monitored, and your ship's direction, cruise, speed, all those things will be automatically altered. Okay, again, like so very interesting and large scale application of logistics. And even like so, there are another thing is when you put like so the logistic when the huge amount of shipment is loaded onto the ship, you also need to see like so what is the stress point of this actually. Is there is if there is a items are not properly uh, loaded onto the ship. Okay, if it is only like so one side, it is all like so weight is in the one side. So then there is a high chances that okay the ship become unstable and there could be a capsize options, actually, possibilities. How to monitor like so the and because it is continuously moving, right? So over a period while loading, you might have loaded properly, but like so in the course of your journey, the goods inside may get shifted because of the dynamic nature. Now, how to measure those kind of stress points in the dynamic condition, and how to steer your ship to ensure that okay, so you don't get into the capsize situation. And I mentioned like so the building and infrastructure. Already we talked about like so how to make it the stress points and like so the deviations in the building. So if there is a you put a pillar and a beam, if the beam is getting like so like there is a stress point and like so the beam is bending, then you need to get into like so the corrective action immediately instead of like so waiting till the last moment where the building entire building can collapse. So these are all like so possible by with the help of its computing devices. And even in the agriculture like so the animal husband like so when you are having a huge amount of cattle farms and sheep farms, right, how to monitor the livestock, etc and so forth, that's also possible with the help of HA. Yeah, this is what I was talking about. If you talk about the agriculture, the smart farms, like so analyzing the counting the animals, checking the animal behavior itself, like so what kind of like so if some animal is sick, if its behavior is very abnormal, I think probably because so the expectation is a minimum human resources maintaining large scale farms. See, we at least in India, it is not very common. Like so because like also in the concept of farming in India, it's very like even if you take a poultry farm, right? Probably you will have like so maybe 50,000 or 1 lakh chickens, and probably that is again monitored by like so maybe 50 to 100 number of human resources. We are talking about like so the huge farming where like so maybe like 10 thousands and millions of lakhs of cattle spreading across like so the hundreds and thousands of hectares and being monitored and managed by hardly handful people. How to manage it actually? Like so, sensing like so there will be a lot of sensors mounted on the cows. I think this is like so one of the case from the Australia where like so the farm is about like so it is containing about 25,000 cows and being found monitored by like so maybe 5 to 8 people. So what are the kind of things they have? They have the deployed drones to see like so the overall area, and there is each cow is marked with the sensor to identify like so the cow ID and its position GPS, and also like so its behavior like so like vital parameters about the cow, whether it is grazing, whether it is having like so the temperature difference, or is there is any change in the behavior, whether it is sick, those kind of things. And all these things are like so getting coming to the data coming to the centralized cloud center, and based on that like so the alarm will be sent, and so these handful of people are able to manage this entire curve form. Okay. So this is a example like so whether cow is feeding or it is like we are not eating for eaten for some time, those are the kind of activity. So again like so when it comes to healthcare, so we'll have like lot of uh, application case of Edge, like okay, so the wearable computer. Like, so the wearable computer means I can wear a, small computer which can write continuously. I think probably most of your smart watches these days can sense like okay, so your heartbeat, abnormality in your heartbeat, and like so the number of heartbeat when you are stressed, etc. and so forth. So in the similar way, so there could be like a whole lot. See that way, even like your smartwatch is a edge device now, it is doing a lot of analysis. In the similar way, like okay, if somebody has undergone a surgery, recent surgeries, recovering from particular kind of disease, you can have like lot of a wearable computer which can measure and sense continuously sense like lot of vital parameter. If there is any abnormality parameter, it can directly send out the uh, signals to the its doctor, is or her doctor, and if there is any modification or the course of medicine change that can be communicated directly in real time. All this is possible with the help of its computer. So of course, AI is there. So but all these things working without intervention of like so you being realize that okay you are stressed. Okay, all these things will be automatically done. So that's the beauty of Edge AI. So that's why I'm stressing on. So these are the fields or these are the areas which can create lot many jobs going forward. Okay. So I think like okay, so sensing like a lot of so this is a atrial fibrillation. That means like if somebody is having like fibrillations, right? So that's how to monitor this, okay, and how to continuously monitor and try to take the ECG and see like so what is the kind of body behavior when it is when a person undergoes the fibrillations, okay, and when to raise the alarm, or how to increase the particular like so kind of medication. So all these things can be automatically, and even like so today we are talking about ICU management, like so in case of a healthcare, how well we can use like so this AI technology for the ICU management. So in the ICU, currently like okay, so the ICU number of ICU beds are very limited because of like the sophisticated doctors who can or the physicians who can support. But When these kind of systems are becoming more and more like so these kind of more reliable and more usable, then like so the cost of ICU stay will come down, one, and number of ICU beds can be increased, and it can do much more better management of the patients who are in the critical condition. Okay, these are all the possibilities. It will definitely, it is also having like lot of societal impact as well. Okay. So again, like okay, so when it comes to sound, vibration, and vision, so it can solve like so a whole lot of problem. In case of sound, for the security, like okay, so you can have a edge device, edge AI for robbery or burglary detection. Okay, so from the security, home security point of view, if there is a broken glass or somebody is entering into like okay, so and they are keying in like so the certain kind of password in a wrong keystrokes, those can be analyzed. So that is purely from the sense voice itself, like so based on the voice signals. Again, in case of industry, based on the noise coming from the particular device or the vibration, you can do the anomaly detection. Again, like so the medical so snoring condition, I think probably like even the sleep apnea can be effectively measured. Like so again, it comes under the area of wearable computer. You can just wear a small device, and that will sense your snoring sound and the change in your snoring pattern, and based on that it will try to wake you up, like if you are getting into the case of a sleep apnea, or like so it can send out a warning message. These are all possible with the help of HGI. And even like so studying the uh, insect behavior, like okay, bee or mosquito sound, how to repel the mosquitoes. That is also like it's a very very interesting studies being done, how to integrate this kind of thing, like so how to keep the mosquitoes away based on like so its sound patterns. Okay, by so if the mosquito enters into a particular area. Okay, so based on that mosquitoes wing flapping, right? So it will like your edge devices will try to send out another kind of signals in another frequency, which will keep the mosquitoes away from the. So these days, what we are trying to do, like so to keep mosquitoes away, you are using like mosquito repellent. So which has like so potential health hazard. Also like so the mosquitoes might have like so they gain the immunity over those kind of liquidator or the mosquito repellent. Now, like so, there is another interesting kind of like so the keeping these mosquitoes away is like based on studying the mosquito patterns. So this is what I was talking about, classifying the mosquito wing beat sound using tiny ml. And the beauty here is like so they put another vibration center. It will try to generate a vibration. It will try to vibrate. That vibrator will be turned on, and that vibrator will generate a frequency which the mosquitoes can send it mosquitoes can sense, and it will shoo away that mosquitoes without even like so the humans sensing that okay, so there is something is working. Okay. Those are the kind of interesting things are possible with the help of this HA. So this keyboard, I think probably like so based on the keyboard stroke and the sound or the spacing between like so the keyboard it flaps, right? So you can sense and try to see like so what is changing. And similarly, vibration we have talked about already, like uh, lot of sensors can be used to measure the vibrations, and accelerometers are put onto the animals and also onto the machines to see like so the anomaly or abnormality condition monitoring. Even like so in the wild, so there are a lot of studies being done, like so whether the what kind of animal conflict to avoid the animal conflict, and if there is any. This is mainly like so for the national parks where like so these animals are like so the restricted areas where these animals need to be monitored, which cannot be like so done through the uh, manually, like it may not be possible, right? So how to put the sensors and how to monitor, how to what kind of sensors signals can be sensed, and when to raise the alarm, and when to intervene. So these are the kind of things, lot of studies being done. I think this is what I was talking about, the mechanical stress, right? When you are transporting, trying to see like so where the stress of the goods, okay, how to correct it, how to change your course, okay, how to distribute your goods such a way that like so the stress is evenly distributed, not stressed at only one location. And again, factory like so with respect to vibration and like the predictive maintenance. Again, with respect to vision, so if you sense there is a possibility of forest fire, how to detect it and when to spray like so how much of water. So all these things are possible. Like so on the drones, like so the drone technology is another area where like so the lot of edge devices are getting on board into this drones, and lot of uh, surveillance operations can be performed on top of it, and disease detection. Okay, so this probably like okay. So again, you can leverage your mobile phones, mobile cameras in your mobile phone, mobile computation available in your mobile phone to detect and see like so what kind of disease it is and what kind of preventive maintenance or the corrective maintenance you need to take care. So see the things are moving in the direction like so where large scale farmings and large scale business problems can be solved with the help of lesser and lesser number of effort. At the same time, like so we are in the crossroad where how we can put it into the operation like was by using the existing devices or coming up with a cost effective devices which can effectively increase the overall operations. So again, like classification of fruit and like so its freshness, etc. With the help of so lot of solutions, lot of models are already available. How to port it and how to sense even when you are shopping, how to decide like so whether this particular fruit. See, probably like okay, if you go to supermarket and buy a apple, always it will be very shiny, but inside it may not be very fresh. How to sense it actually? Okay. So without even touching, how is it possible to sense? So these are all possible like with the help of very interesting algorithms. Okay. This is another case study of coffee disease classification, again from the edge device and their mobile cameras. Okay. So these are the different type of boards one can see like so for the if for the image. So one can see image classification with ESP32 cam, ESP classification with the Protena H5, H7. Okay. I will share this document. Probably we'll have like so the links to those hardware. Probably if you are planning to build any of the system, you can use it. Okay. These are the some of the references and some areas for probably where you can pick up more details. And if you have any specific problem, so you can always reach out to me. Like so, if I have any other detail, I can definitely will share. All right. So this is what I just wanted to cover today. Uh, So if you have any questions, I would be glad and happy to take questions, couple few questions. Okay, so yeah, if you have any questions now, or like if you have any questions or clarification, or like so further inputs is required, you can always reach out in my email. And I think probably I'm more happy to share like whatever the information I have. If no questions, I think probably let me take this opportunity to thank you all for your patience listening. And again, I take this opportunity to thank organizers and Dr. Subhadra Madam and Principal and Dean, Dr. Amar sir, for giving me the opportunity to share my views and little experience, whatever I gained in the area of EA and JA with you guys. Thank you. Thank you all. I think, madam, you are on mute.
Thank you, sir. Thank you for reminding.
Yeah, thank you. Thank you.
Good,
Like
good
so,
morning, all. Yeah, sir, please.
so yeah. So I'm done, madam. Like so, if no other questions or anything, I think probably yeah, we can wrap it up.
Yeah, thank you, sir. Thank you so much.
Thank you. Thank you
So,
very much. Thank you.
good morning, all. So, it's my privilege to deliver the vote of thanks on behalf of Department of Electronics Engineering, VLSI Design and Technology from RMK College of Engineering Technology for today's enlightening session on generic talk series 28. At the outset, I extend our heartfelt gratitude to our magnanimous management and our respected principal for their constant encouragement and support in organizing such inspiring sessions. I also thank our Dean Academics and Dean Research for their valuable guidance and motivation. Our deepest appreciation goes to our distinguished speaker, Dr. Dinesh, Managing Director and Head of Business at Samsung Electromechanics Bangalore. His talk on Edge AI concepts, architectures, and applications have given us invaluable insights into the evolving world of artificial intelligence. He explained the classification of AI into the narrow intelligence, general intelligence, and super intelligence, helping us understand the present capabilities and future directions of AI. He also compared the typical IoT systems with edge AI based IoT, emphasizing how the edge AI ensures low power consumption, reduced computational burden, minimal latency, and simplified infrastructure requirements. Importantly, he clarified the large scale models like Llama and GPUs, such as RTX 4090, are not suitable for edge AI. Instead, highlighted the role of lightweighted approaches such as LoRa models, which make AI practical and efficient on edge devices. In addition, he discussed how edge devices can be effectively leveraged and it helps in real-time decision making, privacy, and personalization. He clarified about the TinyML and the related hardwares that can be used in terms of Nano Arduino or Raspberry Pi, etc. He mentioned some of the important applications like predictive maintenance, human animal sensing, and asset tracking and monitoring. Most importantly, his assurance that AI will not eliminate jobs but create the new opportunities has been truly motivating for our listeners. I would like to thank him on his wonderful session. Thank you so much, Dinesh sir. I would also like to place on record our sincere thank to our technical team, Dr. Regin Pal sir, Professor, Department of CSC, for his support in coordinating today's event. Mr. Singaravelu, who is the coordinator of this event, and Dr. S. Keetana from EVLSI and Design and Technology Department for the dedicated efforts in making this event a grand success. Finally, I thank all the faculty members, listeners, and the participants for their enthusiastic engagement and for joining us both offline and through YouTube Live. With that, we conclude today's generic talk series. Let us look forward these valuable learnings and continue to explore the limitless possibilities of Edge AI. Thank you so much. Thank you all. Kitna, it's okay.
Okay, ma'am. Thank you, ma'am. It's enough, ma'am.
முடிஞ்சிருச்சுங்களா சார்?
This, ma'am.
ஓகேங்க சார்.
Um,
Thank you, Regin sir. Thank you, Kitna.
Thank you, ma'am.
Thank you, ma'am. நல்லா இருந்துச்சு session.
Thank you, sir.
கிட்னா கால்
ma'am.
பண்ணுங்க. ஓகே நான்
Okay, ma'am.